Okay. Okay. Mic testing. Okay. It's working fine. Mm. Yeah. Just see something. Okay. Uh, Give me a second. Play something. So then it's been a long time since I did the streaming, but yeah, it was my vacation of my college, so I was just, having a quality time with my family. Now we can continue. And today we are not going to work on a project. Today we are going to learn from Freya again. She was actually live streaming recently, and we got, I just made a live comment on it, and she just replied it, and I was so happy about it. So yeah, see, she was actually doing the, and she is going to do it today as well, the live streaming. So it's going to be interesting to see. She's doing live streaming for like 1 month ago. She's consistent about it. Let's see what she made.
Okay, hello.
7 hours and
so there's different ways of doing it. Array length to wrap negative stuff into the array. Now it works, yeah. Why do programming languages insist on bad modulo? Use the good modulo. You're no longer a negative color. That's true. You.
But yeah, she's just awesome. Yeah.
Vector project.
We were in 6. I think we have completed 6.
That's exactly what you do when you multiply matrices together. So we simply multiply by our offset. So what that means is that it's going to first rotate based off of all of the placement vectors we set up before, and then it's going to rotate around its local y-axis. Because that's the orientation we defined here.
We have done the interpolations as well, I think. No. We have done the solution part.
What am I doing? Oh, I rubbed my eye.
We are going to do the.
And I'm wearing makeup, and I wonder if I messed my eye up. So I'm gonna look at my eye. Oh, perfect.
Yeah, this was the thing. Let me just.
That's exactly what you do when you multiply matrix for turret yaw offset.
Oh yeah, it was a placer.
Okay.
If I remember right. Yeah.
Lunch. What am I doing? Oh, I rubbed my eye. And I've been wearing I'm wearing makeup, and I wonder if I messed my eye up. So I'm gonna have to look at my eye. I'll verify.
Give me a second.
What am I doing? Oh, I rubbed my eye. And I've been wearing I'm wearing makeup, and I wonder if I messed my eye up. So I'm gonna have to look at my eye. I'll verify. I don't want to mess up my eyeliner. Okay. Okay, yeah, we gotta resume class. I'm a little bit late. Oh, I need to go get my drinks.
Okay.
Two monsters. Okay, everyone, react to the message in Discord if you are present. Show your presence using emotes of cats? I don't know. Looks like there's cats this time. Okay. All right. Let's resume. All right.
Give me a second. Ooh. So you've been looking here. You can see we have done some changes in my PC. So it's like something pretty different. Also,
We got this. This is the final planned lecture, and then the next one is going to be on Friday, and that's when we're going to do whatever topics you want to talk about. Might be esoteric topics, might be just other useful topics, whatever you prefer. That's gonna be Friday. Wait, not tomorrow? No, I thought we only had Friday. Oh yeah, wait. Yeah, so Wednesday, sorry. Yes, tomorrow we're gonna have only assignments, but I'm gonna be available on Wednesday. So I'm gonna be available for basically the same amount of time as the lecture time. And then on Friday, we're gonna have the last lecture. So tomorrow is not a lecture, you're just gonna have assignments to work on. And I will be available for help throughout that entire time. Yeah, that's tomorrow. But Friday is gonna be the last lecture, and that's gonna be the mixed random topics. New assignments are the same ones. There's gonna be new assignments, and you are welcome to work on the old ones as well if you want. Thursday, I'm not gonna be available. You can keep working on the assignments if you want to. It's up to you. Ideally, you would work on the assignments. That's what I would recommend. I think my plan is to give you a large bucket of assignments where you can't possibly do all of them, where you just pick which ones you want to do. Like, if you want to learn more trig, you pick that one. If you want to learn something else, you pick something else, and so forth. Are gonna help through text or through Teams? I imagine I'm just gonna hang around in Discord. We could do voice channels. I can stream in Discord. Yeah, I'm gonna be available in this Discord that you're in. Friday, the last day of not having to deal with Teams. Seems like there's every group of students. None of them like Teams. It seems like I haven't tried it out for my lectures, but it sounds like my option is better so far. Except the fact that it's public, which has downsides too. Okay. There's kittens. Look at kitten. Oh, salad. Oh no. Oh no. Salad. Hello. Salad is sitting on Ashley's computer. And then Toast is in the box. So it's a good box. Very, very good box. Kittens. Anyway, that's not part of the lecture. When's Krista gonna give us the assignments? I have no clue. I don't know how the actual canonical graded assignments are gonna work. So I don't know. I would ask Krista, and I can send Krista all of my assignments, and maybe he can turn some of them into required ones. I'm just not gonna.
Tuhan tavita ma YouTube でライブストリームしてるよ。そして仕事いいの？見えない。Resume.
To be available to grade and all of that kind of stuff. Yeah, and so that's up to Krista. I don't like grading stuff. I'm uncomfortable because I don't know if someone cheated or not. It's hard to tell. I don't know if you just copied or pasted or if you actually learned. So for me, I just want to give you the possibility to learn, and I want to be available if you have questions and just push you in the direction you should go if you want to learn things. That's my job. And then when it comes to the like formal requirements of assignments, I'm just leaving that up to you, Christer, because I don't have that much time and I don't want to do it, and so that's why, for better or for worse. But yeah, it's I don't think it's super. Yeah, I think it's mostly just for the formality because you have to, according to the school system. Okay. Are we ready to start doing new things? All right. I think we're ready. Whew. So,
Just give me a second. No? You're back. You can continue.
First, there are two things I want to talk about that I didn't really cover last time. I'm just trying to say that I forgot. I forgot to talk about them.
I need to bring my notebook. This is good. I'm not in the conversation, right? Just give me a second. Let me see. So, Yes. Okay.
So I'm going to just talk about them now. So we talked briefly about the inverse trig functions. We had the arc cosine and both of these are the arc cosine. Usually you type them as a cos or cos to the power of -1. So that's the inverse cosine. The inverse cosine basically gives you an angle given an x-coordinate, right? So if you have the x-coordinate of v, it gives you this angle right here. The problem though with the arc cosine and the arc sine, which is the opposite of the sine, so that is arc sine of some value x. All right, I think we're ready. Whew. So, first there are two things I want to talk about that I didn't really cover last time. I'm just trying to say that I forgot to talk about them, so I'm gonna just talk about them now. So we talked briefly about the inverse trig functions. We had the arc cosine and both of these are the arc cosine. Usually you type them as a cos or cos to the power of -1. So that's the inverse cosine. The inverse cosine basically gives you an angle given an x-coordinate, right? So if you have the x-coordinate of v, it gives you this angle right here. It gives you this. So if you have the x-coordinate of v, it gives you this angle right here.
If x-coordinate of v is 5, where's my calculator? So if the x-coordinate of v is 5, then inverse cos of 5 will be inverse cos. Wait a second.
The problem though with the arc cosine and the arc sine, which is the opposite of the sine, so that is arc sine of some value x. The problem though is that it's actually kind of complicated to just go from a vector component directly to an angle, because there's ambiguity here, right? Like, it's kind of hard to know which quadrant you're in if you only have that one component, because if you look at this vector v, if you draw another vector here, then this one, what's ambiguity? Ambiguity is when it's hard to tell the difference between different cases. So in this case, if you have two vectors, you have one vector here and one vector here, these both have the same x-coordinate, right? So they have the same x-coordinate, and so we don't have enough information to know if we want this angle or if we want this. We don't have enough information to know if we want this angle or if we want this angle, like negative alpha, right? And the same x-coordinate.
Have I made this figure? Because it is really important. Have I already done that? Let me see. I already made this figure. Oh yeah, I did. I did.
And so we don't have enough information to know if we want this angle or if we want this angle, like negative alpha, right? And so we can't tell the difference between these two cases because both of these vectors have the same x component. And so when we were talking earlier about going from an angle to a vector, okay, I can't find that. So if you want to go from an angle to a vector, then you would do something like v equals, I'm going to do a column matrix because why not? Then the x component was the cosine of alpha, right?
Cosine of alpha.
And then the y component was the
sine
of alpha.
Minus. No.
Just gonna erase that. So this was kind of how you go from an angle to a vector, right? And we use this in our code. So we had that in somewhere here. I believe it might have been in the trigger, or no, we had it in the clock. So that's this function right here. Angle to direction. We just use the cosine and the sine of the angle, and then we get a direction. But what about the other function? Like, what if you have the, you want an angle, so you want to go from a direction to an angle. So you pass in a vector. So that's our vector v. So how do we do this? Well, there is a math function that is somewhat confusing. It's confusingly named and the parameters are confusing, but there's a function called a tan 2. So it is called
Something like that. I forgot.
Confusing, but there's a function called atan2. So it is called atan2. It's a shitty name for a function, but it's called atan2. It's similar to the arctangent, the inverse tangent, but it has a bit of an extra thing that it does that makes it a little bit easier to resolve. So it basically resolves ambiguity. So a-tan2, we can use that to... wait, is there any difference between using a 2D vector instead of a 2D vector? What? Do you mean 3D? I'm not sure if you mean 2D versus 3D because you type 2D twice. So angles get a little bit more complicated when doing them in 3D because they, like, it's almost only useful to talk about them in 2D because all angles are in a plane, right? And so usually in 3D, you would just decide, okay, we're rotating around this plane, and then we're doing 2D math in that plane. So it's effectively just 2D, but everything can apply to 3D as well. Just a matter of picking which plane to work in. Yeah. Asking what ambiguity is and then typing that sentence is the master stroke. That's true. Okay, so a-tan2 is a function and it takes a vector, or a little bit confusingly, it takes the y component of a vector, and then it takes the x component of the vector, and then it returns the angle. So angle equals a-tan2 of the y component and the x component. So this is basically the way to convert from vector to angle, and this is angle to vector. So these two are functions that I use a lot every time I do anything that involves like circular placement or movement or anything. It's super useful. And so these two functions are good. The confusing thing about a-tan2 is obviously that you're doing the y component first instead of x. This is weird, it's shitty, but it's just the way it is, because nothing is consistent and everything is garbage. And so it's just, you just have to accept that. The way that I usually just do this is that I make a wrapper for this function. So I make the function that I started typing in code here, where I just do return, math, here, function.
This is my x component. X. This is y component where a-tan2 alpha equal to
So I make the function that I started typing in code here, where I just do return, math dot a-tan2 v.y v.x. And then I never use a-tan2 ever again. I just use the direction to angle function. This is how I usually do it because I think it is way less ambiguous. There's no chance of mixing up x and y, and I just like it. What's the angle in reference to? It's always in reference to the x-axis.
Give me a second. Na. Let's take a 10 minutes break.
to ever again. I just use the direction to angle function.
Okay.
This is how I usually do it because I think ever again. I just use the direction to angle function. This is how I usually do it because I think it is way less ambiguous. There's no chance of mixing up x and y, and I just like it. What's the angle in reference to? It's always in reference to the x-axis. So in whatever space you define the vector in, it's going to be the angle relative to the x-axis. How to visualize A10? Well, it gives you an angle based off of a value, right? But it's complicated in this case because A102 has two inputs. But effectively, given a vector, you can get an angle out of it, and it's always the angle to the x-axis. So this is the angle you're getting. So this angle alpha. And so the angle is going to be in radians, and on this side, you're going to have positive values, and on this side, you're going to have negative values. So it basically goes all the way to tau over 2, and then on the other side, it goes to negative tau over 2. So it basically covers the full turn in radians. It's just that it centers on 0 here, and then it goes to positive values on this side and negative values on that side. Those are the angles you're going to get out of that. This case because A102 has two inputs. But effectively, given a vector, you can get an angle out of it, and it's always the angle to the x-axis. So this is the angle you're getting. So this angle alpha. And so the angle is going to be in radians, and on this side, you're going to have positive values, and on this side, you're going to have negative values. So it basically goes all the way to tau over 2, and then on the other side, it goes to negative tau over 2. So it basically covers the full turn.
Tau value 3.14. Tau value is 6.2.
In radians, it's just that it centers on 0 here, and then it goes to positive values on this side and negative values on that side. Those are the angles you're going to get out of that. When I use A102, it just calculates it on the world, right? What if I want to calculate of something else? This is just like most of the functions that we're doing, they have no knowledge of space. If you use A102 on a local space vector, you're going to get the angle relative to the local space x-axis. If you're doing it with a world space vector, you're going to get the angle relative to the world space x-axis. So it all just depends on the space of your input. The functions will follow the space that you give it, right? And so there's nothing like, they don't have any knowledge about space. And so it's just based off of what you pass into them. Okay. Yeah, I can do more assignments on trig if you want. So the directional vector that we give into it has to be relative as well. Relative to whatever space you want to measure in, right? Okay. Maybe I should actually clarify this for the future. Because I'm guessing you're gonna want this whole sketch board after we're done, and if it contains more information, then that's valuable, I think. Just making some space. What do you mean empty? You're empty, Photoshop. Just making some space. What do you mean empty? You're empty, Photoshop. Thor is screaming. Thor! So this is angle 2 direction. And this is vector to angle. It doesn't have to be normalized for this input. It's going to work regardless. Okay. There you go. Good things to remember. Again, I use these a lot, and I almost always make helper functions for them so that I don't have to type a10-2. It's a confusingly named function with confusing parameters, but it's like that because it's historically been like that, and then people are very reluctant to change things. And so, yep. All right. Let's see. Okay. So that was one thing that I hadn't talked much about, that I should have covered in the trig section. The other thing is our dot product here. I wonder if we should maybe we're gonna copy these. We're just gonna steal them, I think. So we're gonna need them. Okay.
But you know what? I wanna just know curiosity, like what is the real meaning of e-tensor?
Okay, so if you've ever had to calculate let's calculate this, and this segment is the negative, but distance because this is negative.
E-tensor is not interest. Active. Theta equal to Tremor of C. Radians. So basically, this is giving radian. It's like the angles is given in radian. You can convert it into a degree. Notes. Where is it? Where is it? Das ist bei uns. Ja. What is it? Yes. 60 degree. 90 degree, 90 degree, 90 degree, 90 degree.
Dot product. All right. I'm guessing you remember the dot product. We talked about it a lot. There's actually one, a little bit of a, so the dot product kind of has a hidden, lesser known sister that we rarely talk about. And it's kind of confusing as well because there are so many definitions for it, and there's no proper name for that function. But when you do the dot product between two vectors, like let's say you're doing the dot product between v and the x-axis, the dot product is, the result of the dot product is the cosine of that angle, right? Because as you can see, you're projecting v onto the x-axis. And because both of them are normalized, again, that's when we have the vector projection or the scalar projection. So the dot product is basically related to the cosine function, right? And so that's why you can define the dot product using the cosine. which is kind of cool, right? Like you have this like relationship to the trig functions, even though the dot product is simply just multiplying the components together, right? It just so happens that it directly relates to the angle between them, and that's kind of cool. But that kind of angle to the is basically related to the cosine function, right? And so that's why you can define the dot product using the cosine, which is kind of cool, right? Like you have this like relationship to the trig functions, even though the dot product is simply just multiplying the components together, right? It just so happens that it directly relates to the angle between them, and that's kind of cool. But that kind of begs the question, doesn't it? Like, what about the sine function? Like we have the cosine here. Like what function would do this effectively, where you have the length of a, and then you get the length of b,
And then sine.
like so,
Sine theta.
and then you have the sine
Theta.
of our angle theta. So what is this? Turns out, this actually has a name. The problem is that it has too many names. Like it has a shitload of names. So this can be called the determinant.
Excuse me.
It can be called the perpendicular dot product.
Determinant.
It can be called the 2D cross product, which is technically incorrect. And it can be called the wedge product. It can also be called the exterior product. It can also be called the antisymmetric product. Those are all the names that this function has in 2 dimensions. It is really confusing because it has so many names. As of late, I'm leaning towards calling it the wedge product. So I like the wedge product because it actually has a symbol, which is a little upwards wedge like this. It's mostly used in geometric algebra, but I think it's okay to sneak that into our regular vector math. So we have a wedge b equals this whole thing. Okay, I just need to bring up my notes because I always get the component order wrong when I write the other version of this. Math course. Where's my... There we go. Okay. And turns out the determinant, specifically in 2D, or the wedge product in 2D, can also be written similar to the dot product. We can use the components to write this. So we have B, wedge A. So this one can be written as A x times B y, and then minus A y and B x. There we go. So this is the wedge product. In 2D specifically. This does not generalize to 3D. And so this is actually very closely related to the cross product. If you look at the definition of the cross product, it kind of looks like this for every component. And so if we go back to our cross product, you get this for every component.
E of y, E of x, B of y, minus A of y, B of x.
If you look at the definition of the cross product, it kind of looks like this for every component. And so if we go back to our cross product, you can see that we actually have the wedge product right here. And so the cross product and the wedge product are very, very related to each other. But the different definitions of the wedge product is actually, it just varies widely depending on which like region of math you're in. But in general, I would call this the wedge product. Wedge product, or it can be called the determinant. Okay. So, is the wedge product non-commutative then? Yes. Okay, so the wedge product basically gives us that lost other component of our vector. So the wedge product gives us the sign value here. And so just like the dot product, we use the dot product to tell like how similar are two vectors from each other, like in the unit circle, right? If we have a vector that's pointing kind of in the same direction, we have a value that's greater than 1, right? If it's pointing in the opposite direction, it's going to be, or sorry, not greater than 1. On this whole side, the dot product is going to be positive, right? Between this vector and some other vector. So it's going to be positive on this whole side, and it's going to be negative on this entire side. So the wedge product, instead of checking if it's in front of or behind, the wedge product checks left and right. So that's kind of how you can interpret that. So instead of checking this plane, it's kind of checking along the object itself, or along the other vector. So now if we use the wedge product, then it's going to be positive on one side and negative on the other side.
That's interesting. Dot. This will be positive. This is negative. But the wedge here, product. B. This left will be positive and right will be negative.
And so here, you can actually use the wedge product to tell, like, for instance, if you have a car, like an AI of a car, and you have something you're going to drive towards, you can just check, is this thing to the left or to the right of me? And if it is, then we determine which direction we should turn. Is it always positive on the left? All of this depends on your orientation and coordinate system. I forget which side is which. It could be the other way around. There's a 50% chance. No, there's a 60% chance I got this right. I think it's positive to the right. Yes, it should be positive. Oh, sorry, positive to the left. I'm 80% sure of that now.
Let's just see. counterclockwise is positive and clockwise is negative. So yeah, right will be negative and left will be positive. So
Okay, so this is kind of the lesser known sister of the dot product, which is very useful to know. Yeah, good to remember. Is this also in Unity's math? I have it in my library. I think they might have added it recently. I think they might have called it perpendicular or something. It might be in Vector 2. Oh no, this gives you a vector. Okay, yeah, no, they might not actually have it. I don't think they do. Wedge product, determinant, no, they don't. That's
does not have math, have for vector 2 functions specific name that's specific. Okay, this is useful. And I interesting. 28 levels. Is there more to see? I just want to explore. What is this? Interesting.
That's why you should use my math library. My math library has it all. So you should check it out there. It's called Determinant in my math library.
Oh, I can add her math library in my projects, I think. Very soon, yeah, there. Math have for Unity. Own and download the repository and put it as a folder. Trajectory determinant.
Because that was before I started looking into geometric algebra. And now I want to call it the wedge product. Okay. Right. That was just one thing that I also forgot to cover. That's good to remember. All right. Okay. Trying to figure out if we should do a 10-minute break before we continue. Yeah, let's do 10-minute break. Now we can resume to like a normal break schedule. I think that would be good. Since it's non-commutative, which one out of A and B is the reference vector to which you're comparing direction? Well, it would just depend on, like if you have two vectors, I guess we can give them some color. So if you have two vectors, you have A and B. Pretend these are normalized. Like if you want to check which side they are of each other, then I believe the wedge product between A and B, I think that is going to be, I think that's going to give you a negative result. And if you do B and A, you're going to get positive. I think that's the way it is. I forget which one it is. Because B is to the left of A, or sorry, B is to the right of A, and A is to the left of B. And so that's why they give different answers. They're going to have the same magnitude. The result is going to be the same magnitude, but they're just going to have different signs, right? Yeah, and so similar to the dot product, if they are perfectly perpendicular, so if you have A and B, you're gonna have a value of 1. Or -1 if it's on the other side. So it's going to either be 1 or -1. Yeah, and then it's going to start going back to 0 if they're pointing exactly in the opposite directions. So in the opposite directions, it would be 0. If they point in the same direction, that's also 0. So you can see that it's basically like the dot product, but it's rotated 90 degrees. And so that's why it's sometimes called the perpendicular dot product. Yeah. Okay. Should we do break? Should we do break? Vote. Break or not break? I don't know if we should resume to the normal break schedule. Have opinions. Okay, break. Okay, let's do break. 10-minute break from now.
For the wedge product, if B is like 180 degree from A, it will be 0.
Goodness. Toast! There's some cats going on in the background. I don't know what's happening. I think there's a salad in the bathroom. They're talking to each other. Toasty, salad.
We should continue from tomorrow one thing, but I need.
I still have something in my eye. I had something in my eye ever since. Can I also do scalar projection with the determinant? Yeah, I mean it gives you a scalar result. So yes, it's just like usually that's not called scalar projection. Usually that's reserved for the dot product. And so if you say scalar projection, they're going to assume you mean the dot product. Yeah. But maybe you could call it the perpendicular scalar projection or something. Okay, I think the kittens are playing in the bathroom. Sometimes they like randomly run out of the bathroom. I've also found them in the bathtub quite a few times. I just walk into the bathroom and then there are 2 cats in the bathtub. Either just napping there or they're like wrestling and tumbling around. I don't know why they hang out in the bathtub. Salad! I can hear Salad. He's like chirping away. That was a yell. Boys, how you doing? There's some big wrestles going on. Could you hear that? I don't know if you heard that. I'm gonna see how they're doing. They were just lying on the floor. I'm guessing they were wrestling, but I don't have any evidence of that anymore, apart from the sound. Toasty! Salad! Hello! Here come the boys. Hey boys, how you doing? Vloop. Just one snack and then vloop. Okay. What a good pair of boys. Okay. Okay. Okay, toast. Bloop, bloop, bloop. Okay. That's valid. These are two spots. Oh, toast collapsed. Oh no, toast, you collapsed. Please flatten him. Is it toast? Because of the color markings? Yes. Because toast kind of has a toasted snoot. Tastes like a little bit of toasted bread. Yeah, it looks a little toasted. That's why it's called toast. It doesn't go any deeper than that. Yep. Cannot notice salad is not green. Okay, so the name of salad was inspired by a tweet. This was inspired by two things. One is the meme with the two ladies that are yelling and pointing at a cat, and there's a cat sitting in front of a plate of salad looking great. That cat's name is that cat is called Smudge Lord. You should follow Smudge Lord on Instagram. Anyway, inspired by that, the salad cat, we actually have a canvas print of Smudge Lord over there. Anyway, so it's a cat in front of salad, so it's kind of funny. Anyway, And then the other inspiration for Salad's name is from this tweet.
A real balls to
I just love this tweet. It's a very good tweet. And so kind of from the result of these things, we ended up just naming him Salad. We consider naming him like bok choy, but it's a little bit like annoying to say every time. And there's something endearing with the name Salad. Like, I just love it. It's really good. I kind of just said it as a joke. And then it kind of stuck. You just like joke like, oh, maybe we should name him Salad. Like, haha, that's a dumb name for a cat. And then it's just like, well, I actually kind of love it. So, yeah, and so it kind of stuck. And so Salad and toast. Heard of bok choy, but what we got here is some sort of chunk boy. That's the boy over here. He's the chunk boy.
Yeah, that's you. That's you.
Oh, you caught my Hello Boy reference. I'm glad, Nicholas.
It's Salad.
Okay. We should resume. Okay. A real bonkus chonkus. Just a real chonkster. Okay, we're resuming. Please react to Discord message. Specifically with cats, because we've been talking about cats. So you're gonna have to find a cat emote. I'm seeing 4 frogs here. What's up with the frogs? We're doing cats. There's some fake students that are reacting with frogs. The audacity. Okay. Where are we headed next? Oh yeah, we have a few more things about the determinant that's useful to know. Okay. So, there is another interpretation of the value of the wedge product that is actually kind of cool and it's actually one of those use cases that you use when measuring area, specifically for triangles. So if you have if you have 2 vectors, you have a vector, we're gonna use colors. If you have a vector here, let's call this A. Then you have another vector, and then let's call that B. Very unique names, I know. Then one thing that the determinant or the wedge product actually represents is the area that these 2 vectors form with their parallelogram. So if you imagine A and B, if we just stack them onto each other like this. So this is B and this is A. Then the area that they form here is the determinant between those two. And so that area, that's
Understood. We could continue this from tomorrow, I think. It's going to be later, and I have to work on my new project. I can show you. So this has been done. Control S. I can just show you. Okay, for you, I'll see you tomorrow. No, cancel. See you tomorrow. Just comment it. So this is the project I'm working on recently. So it's my new game project I've been working on for so long time. Now it's been like, and I'm still stuck with the controls and everything because I'm trying to figure out myself. I don't want to use any kind of assets, but this is what I made. It's a little bit offset right now, but yeah. Wait. Okay. So the thing is, like, I'm putting it, I'm putting it here. It should be going that way, okay? It's going that way. It's a little bit hard to control because of the sensitivity of mouse. Wait. It was actually working fine back then, but yeah. So it was the project I've been working on, and it was, I'm still figuring out, the control. I just have to perfect it. I just have to perfect the controls and everything, so I can implement the state patterns later in it. So, yeah, this is a lot of scripts I've made. So yeah, this is the tools. This is the tools. Actually, these are these are not mine, but yeah, I actually want to learn how to configure inverse kinematics with my code. I want to learn it, so I'll look into it after I end my stream, and then and these are just my normal controls and everything for your animation and everything. Yeah, these are just I've been working on it. So yeah, but the stream, no one is watching. I'm just chatting to myself. Okay, this is it for today.